Hi, good afternoon, everybody. I'm Paul Barrett. I'm CTO for Enterprise Business at NetScout. And I'd like to introduce Deb Briggs, who's our CISO. And she's going to talk about some of the challenges she sees in our industry, and then I'm going to talk about how NetScout is helping to address them. So over to you, Deb.
All right, they're going to make me figure this out. I don't do the controller of my own house, so this is, there we go. I have a couple slides that build. I might be kind of challenged. So what I wanted to talk about today is sort of the legacy security approach. Things that, have been happening over the last 5 years and why it's not going to continue to work for us and what we can do to actually make some changes. One of the things is we have way too many tools. I'm not quite sure I believe the 75 tools per enterprise, but I've never counted how many I have. We have too few security staff. We all heard it. There's a tech shortage. We're all, struggling for those few people that are really talented out there. And so we continue to invest in security, but the flip side is also true. We just have to turn the news on, open the newspaper, and we're hearing about all these data breaches. Data breaches continue to grow year over year. How many people, haven't gotten a letter that said, you were part of Target, Home Depot, OPM? We've all gotten that. So we all know that the data breaches continue to increase. Our data is out there. And the cost of a data breach continues to climb. So what we're doing today just isn't working. So the way I like to look at it, and I'm going to build this slide out and hopefully not go too far. All right. Is I like to look at it using the cyber kill chain. And so this is actually the steps or the chain that a bad actor will use when they get into your network. And so if we think about the way we've traditionally looked at security sort of being an M&M, the hard outer shell and the soft squishy inside, we're really good at protecting our borders. We have firewalls. We know how to do that. We've all done it in our sleep. But what we're not so good at is once someone is in, how much time they're spending on our network before they actually exfil data. And the amount of time they spend within our enterprises before it's exfilled is called the dwell time. And there's two numbers that I've heard, and it's funny, the numbers aren't even close, which is why I'll say both of them. One is the average dwell time is 99 days, and the other one is 197. I think the 197 is correct. So what we're doing from a security perspective isn't working. Looking at just the north-south traffic isn't winning, isn't getting us there. And my biggest concern is this is all happening before we even tried to go to the cloud. So now we add into this our ability to want to go to the cloud and put our data out there. So, what can we do? So one of the things that I like to think about is who is really good at looking at east-west traffic. So if you look at what, from a security perspective, we've always been sort of the hard outer shell, like I said, our firewalls defend, sort of the moated island. It's not working, but if you look at what the network teams are doing out there, the network teams traditionally have known what's on your network. They know the traffic. They know who's talking to whom and how often and at what time. This is the data from a security perspective that we now need to get a hold of. And the great thing is most of our companies already have it. They already have the tool. We just have to reach across the aisle and become friends with those networking people. So that's kind of interesting to me that I saw this, and it said 91% of enterprises with at least some formal collaboration between network and security groups. I think that's kind of high. I'm not sure that I see that much collaboration when I talk to other CISOs, at least in the Northeast and in the Boston area. But I think that's what we need to do. We need to actually get really good at getting the data that we have. So what are the problems that I'm challenged with, and I'm sure you are? So security has moved beyond the hardened exterior, looking at the north-south. We actually have to look at what's east and west. East and west is that all that kill chain, what they're doing inside your network before they exfil data. Security needs to get the data that the networking team already has. So it's reaching across that aisle. And we need to share the threat intelligence feed. as I said, the number of hacks are continuing to go up. Hackers and bad actors have the dark web. We need, as a company and as a user group, we need to figure this out. How can we take the intelligence that we have, what I have, and share it with you, and vice versa, and in a community of, and it's something I think we need to face together. And for those of you who don't know who that is in the lower right, that's Johnny Carson doing his Karnak impersonation. And I like to use Johnny because I always think of the data that traverses our network much like a packet. And the envelope is the header information I can see. So if I do this, all I'm seeing is that header information, source, destination, ports, and IP addresses. Great information, but it's really what's inside that letter is what I need to determine from a security perspective what's actually happening. So I'm not going to talk about too much of this slide. I'm going to invite Paul back up because I think Paul has a lot of really great solutions that help. One good thing about NetScout is we drink our own champagne. So I'm really excited. We actually use we use all the NetScout products within the network and within security at NetScout. But the tools we're deploying now are doing a lot of this. It's taking the tools that the network team already has. Don't add another tool. Reach across the table and use what they have. I don't know how to solve the too few security staff other than what everybody's using. Let's automate. Let's use artificial intelligence. Let's get the tool to have the intelligence to help us. And let's reduce the data breaches and the cost of them. So Paul, why don't you come on up?
Deb.
I'm going to turn it over to you. It's that button.
Which one? Oh, that one. Great. Thank you very much, Deb, for that great insight. So I really want to cover two topics. How do we get visibility without borders in our hybrid multi-cloud environments? And I'll talk about what I mean by that in a moment. But to the point Deb was making, how can we bring NetOps and SecOps together using a common data platform? Now, I'm hoping that most of you in the audience know who NetScout are, and you've heard of our cybersecurity division, Arbor Networks. But basically, everything that NetScout does, or almost everything, is about harnessing the intelligence in network flows. There is extraordinarily rich information in packet flows, whether you're trying to understand how your network is being used or simply trying to plan for capacity, but also trying to understand the health of the applications and the services that sit on top of the network. And when we get into cybersecurity, it gives me terrific visibility of the actions of malware and other internal threat vectors. So you're probably thinking, okay, you guys are a packet analysis company, but how do I do that in a hybrid multi-cloud environment? Because I'm figuring that most of you have got all of these components as part of your infrastructure. I mean, we can start off with probably how the people traditionally think of NetScout, which is using physical appliances. And these are still a terrific solution at major data aggregation locations, such as the edge of a data center and top of rack and large sites. But we recognize the fact that we need to get access to the east-west traffic, exactly what Deb was talking about. And we need to get deeper into the application stack. So we basically developed a fully virtualized software form of our probe. It's exactly the same software that you can buy from us in a physical appliance, but in this case, you can deploy it pretty much anywhere in this deployment. I can deploy it in public cloud. I can deploy it in my public cloud running in my data center through managed infrastructure. I can use it in my colo, and I can, of course, use it in my physical data center. And I didn't draw it on here, but I can also use it in my campus, my main office, and we're even now starting to look at deploying this in branch office locations. So just to dig into this a bit more, as I mentioned, the physical appliances still have a place. If you're sitting at the edge of a data center on a 40 gig link or even a 100 gig link, this is still the most cost-effective way to process all of the packets flowing in real time. But the much more exciting part, especially when we're trying to get to the east-west traffic, are the virtual appliances. It really doesn't matter if you're trying to analyze the packets in a virtual machine or an EC2 workload. we have an agent that can see all of the packets flowing into and out of that workload. So we can perform exactly the same analysis that we would with a tap on a physical network. You can put this in a container. So if it's in a Docker environment, you just set up a promiscuous port on the bridge, and I can see all of the traffic flowing between the other containers and also on and off the engine. If it's Kubernetes, I can see all of the traffic flowing into and out of different pods. In an NSX environment, we have a similar approach. We have a service virtual module that's been certified by VMware. That, you have one of those on each hypervisor. Again, it sees all of the traffic flowing between the virtual machines and on and off the hypervisor. And you can scale this thing from being one vCPU or less all the way up to many dozens of vCPUs, in which case I can get similar performance from a virtual probe as I can from a physical one. So if you're in Azure, you can exploit the VTAP capability, and you can natively receive a copy of packets from the Azure infrastructure. So what do we do with those packets? We basically pull out all the rich information. We store the packets on the probes, so we'll come back to why that's necessary. But we pull out the useful and really interesting and actionable information. And we call that ASI, or Adaptive Service Intelligence metadata. And we send that up to our application platforms. This is where, for service assurance, you're going to use our Ingenious One application software, where there are many, many workflows for looking at the health of your applications and services. And in large environments, you're going to need multiple Ingenious One application servers. Not a problem. We'll give you the global manager where you have centralized configuration, and you can basically launch all of your queries from there. They will be intelligently distributed to the relevant application servers and, where necessary, probes, and all that data will be pulled back and correlated in the central location. So we sort of had a bit of an epiphany, especially after the acquisition of Arbor Networks, and we said, our customers have got this huge footprint of probes and virtual probes and agents that they're only currently using for service assurance. Wouldn't it make sense if we allowed them to use exactly the same footprint of probes for cybersecurity analytics? And that's exactly what we've done. By simply adding an Arbor Threat Analytics application at each of the locations where I currently have an Ingenious One server, I now get visibility from a cybersecurity perspective. I said we've called this solution Arbor Threat Analytics. If you think about what's feeding typically your SIM, your Splunk, your Logarithm, whatever your favorite SIM is, there's probably very little tools that are really performing deep packet intelligence. Instead, they're probably consuming log and other machine data. What we're trying to do with Arbor Threat Analytics is unleash the power of true deep packet intelligence for the purposes of cyber analytics. And there's two ways we do this. The first is to detect. As I mentioned, there's incredible information in packet flows when you're trying to understand the bad actors on your network. We analyze that, and if we see something, we will generate an alert within our own user interface, but we will also send that to your SIM, because we know that's where the security ops team live. The other thing we can do is, because we know you live in your SIM, if you see any event that has an IP address associated with it in your SIM, you can launch straight down into Arbor Threat Analytics, and I'll show you a screenshot in a moment. And you can instantly be, in a few clicks, looking at the packets that are directly associated with that event. And that's really where we think we're going to bring a lot of value to CyberOps, because we know how hard it is to work problems at the moment. You talk to network operations people and they say, well, yeah, the SecOps team ring us up and they ask for a trace, and then we go get it and we send it to them and they analyze it, and then they tell us it was the wrong trace. So then we go and find another one. This is a really, really inefficient model for processing cybersecurity events. We're trying to automate that and make it much slicker, all starting in the SIM. So I'm going to go through these very fast because I don't have very long, but this is just a screen showing the kind of detection that we can do, the kind of events and traffic behavior that really shouldn't be on your network. But this is how I contextually launch from my SIM into Arbor Threat Analytics. I've got the host, the IP address that was fed to us, in the middle for the correct time window. And then I can tell you all the other hosts that it's interacted with, how it interacted with them, what protocols. And I can pivot and select one of those hosts and make it the new center of the new analysis window. And from there, in another click, I'm looking at the transactions, and in one more click, I'm looking at the packets. So you can see how in 3 or 4 clicks, I've gone from my SIM to the packets corresponding to that event, regardless of which tool it came from. It could be from us, but we're very open to this. There's every chance it was from one of the other 75 tools that Deb mentioned. One other minor thing, we decode on the probe, so you're not actually hauling packets back. You're just hauling back this page here. So just to wrap up, there's an industry trend saying NetOps and SecOps should be working closer together. Now, depending on who you talk to, some organizations are actually trying to bring the teams together. Others are saying, well, that's really not going to happen. But we strongly believe we can get those teams using the same data set, using the same monitoring locations. They've got a much better chance of being able to hand information off to each other and successfully collaborating. I'll leave you with one last thought. If I see anomalous behavior on my network, I initially don't know if it's likely to be a service assurance problem or is it a threat. And if it's a threat, it could very rapidly become a business impacting service assurance problem. So this is the whole idea of using a common data set. So I'm going to pause there. I'm a little unsure how long I have left because the clock got reset. But just to finish off, so hopefully I've been able to show you how through the use of software agents and probes, we can basically instrument anywhere in the hybrid multi-cloud environments and access packets. And secondly, how you can exploit that instrumentation base both for NetOps and SecOps purposes. So I don't know if anybody can help me with how long I have. Oh, I have. Oh, because okay, the previous speaker went a little short. So I'll take a couple of questions and then I can hand over to the next. Yes, please. Deb, do you want to come on stage? We have 10 minutes to fill, remember?
I saw the clock reset a couple times. I was like, wow, I'm talking fast.
All right, just a quick question. So this is a great concept and product as well. But in the morning session, a few people expressed the concern that the data format is different from different vendors, right? We're talking about how to normalize the data format so they can be easily be consumed by different product and solutions. But you mentioned you can work with any vendors. How's your approach to that challenge? Thank you.
So I would provide 2 answers to that question of what about a common data format. Firstly, as you saw in the hybrid multi-cloud slide, we can deploy anywhere within the hybrid multi-cloud, whether it's public cloud, private cloud, data center, colos. So you're getting homogeneous data across that footprint. In terms of exporting the data, as a company, we used to hold on to our data really tightly and we wouldn't share it with anybody. Well, our kind of philosophy changed a few years back, so all of our data can now be exported as JSON blobs and serialized in Avro via a Kafka bus. So now it's very easy to pull data out of our systems and combine it with other platforms. So I hope that helps answer the question.
Yeah, one more question. Sorry.
Oh, yeah, please go ahead. Yeah.
Yeah, I mean, it's relatively easy to deal with your own data set. You can deploy different things. How you work with other vendors. So we try to utilize other vendors' data, like the data format is different. So is there any suggestion you can just shed some light and how you can tackle that challenge?
I'm going to
or
maybe just
JSON is going to be the
Yeah,
approach
well,
or something else?
I mean, this goes back to something that came up in the first session today. There's sort of several parts to this. The first thing is it does help if we're using a common mechanism. So I think we've all agreed for the time being that JSON is probably the correct method to be encoding the data. I would reiterate the point I made that it's unlikely, I think, in the near foreseeable future that we're all going to start producing the same data. But what's really important is you describe fully the data you're generating. So if each of us really, really explains what we're producing, it then becomes a much simpler job for combining different data sets. And another part of this that we're certainly, as an initiative for us, is exploiting some of the labels and information, for example, in the orchestration environment. Because again, that helps give you context to the data and correlate measurements that have come from other sources as well. So that's definitely a direction you'll see from us. So there was another question here. Thank you for the question.
And then we have to go back over to this gentleman.
Oh, okay.
Right. So my question basically is, as a customer, when we choose this solution, as a customer don't have necessarily has the control of different administrative domains. And I know this solution based on a software agent which you can deploy to the measurable domains. But in order to achieve this high fidelity data, for those domains which is not part of my administrative domain, like I need to go through the telco network, I need to go to another service provider. How do we handle this? There's kind of like there's a gap in between end to end.
The second part of the question, again, I would reiterate, I'm not sure who was in the panel session this morning. When you're in a situation such as a segment you really don't own, like a carrier link, one of the ways that we can help is to help you build up evidence, because if you've got hard evidence of a problem, in my experience, if you provide that to your partner, whether a carrier or cloud provider, they will act upon it. If you just kind of put in a ticket and say, well, nothing works, you've got to help them. They've got nothing actionable to work with. And I can think of many instances where our customers have used our system to, say, collect that evidence to give the partner the confidence to go and investigate.
Yeah,
point.
so the one caveat, and the one example that I can think about is, so we use Office 365, and before we moved to Office 365, Microsoft actually gave us sort of their reference architecture and the speeds and feeds that we should be seeing. And so we actually put it in our tool, and when we fall out of SLA, we're immediately alerted, and we know that it's something in that Office 365 cloud. And we've been really successful. I mean, I know the first time we went, people were like, oh, we've got to put SharePoint back on-prem because it was just, it was painfully slow. But being able to produce the packets and the data that Paul said, that level of detail to Microsoft, they were able to take that and they were actually able to resolve what the issue is. But without some of this detail, they're going to think it's you. They're going to think it's your network. So I think having that visibility is exactly what you need. And as we move more things to the cloud and move more things to SaaS, you need to be able to differentiate between what is yours versus a carrier versus the SaaS provider. And I think these tools are going to be things that you do need. So.
And just going back to the first part of your question, which is, are they not different? I think I'm sort of interpreting it to say there's different packet acquisition methods depending on where you are. As long as you can get access to the packets, then all the processing after that is identical. The reason, and I had the slide, there were so many names on there, is we try and provide a whole toolbox of different methods of getting access to packets, because what works in one environment isn't necessarily the best approach in another environment. Did we have one last question?
Yeah.
Yeah.
So would there be some constraints in specific verticals, like, for example, financial sector where they need, or retail PCI compliance, where there's a mandate to encrypt the data in rest and data in motion, and then you may have techniques like putting the certificates in your boxes to inspect that. So would that be a breach of those requirements?
No, it is not. We have many customers in both the financial services industry, who are obviously regulated by PCI and have to follow PCI DSS, and also in healthcare, where there are restrictions based on HIPAA. It's pretty standard practice to put in what I would describe as break and inspect, or sometimes people call them managed man-in-the-middle boxes, that basically allow you to get access to the plain text of the packets. Those packets are typically sent to a tool chain. It won't just be our probes. There'll be an IPS as well, and some other security tools, maybe data loss prevention. They'll be sitting in a cage, basically directly connected to each other. And all of these customers who do this, they're all bound by PCI and HIPAA, so no, there's not actually a problem there. Sorry, Deb.
The one thing I do want to add, and this is working between security and network operations. Our tool within even NetScout is still owned and maintained by the network group. Security uses it. Typically, when we look at packets, we are limited by a slice size. So, I mean, that's just something is great security practice is, you know, people don't get full packet unless they need full packet. Least privileges is what we do. So even the security team, we don't have full packet access unless we get to the point where we need the full packet in order, and it's very easy for us to move a slice size from just seeing the header and you know, a little bit of the payload, being able to see everything. But that's one of the nice things about the tool is it allows you to sort of carve out the access and the levels that people should have.
And in certain regulatory environments, we actually even overwrite personally identifiable information before they write the packet to disk. That's required in some territories. I think we had one last comment and then we're done.
Yeah, comment. I just wanted to add that packet acquisition technologies today, switches, appliances have the capability to not only slice but mask the unencrypted traffic, so the PII and credit card numbers, et cetera, would be X'd out, so there's no danger of exposing that. You just have to have a policy as you approach these things.
Yeah. Okay, thank you. So
Thank you.
we're out of time. Greatly appreciate your attention. Thank you.